Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be understanding a problem on wedge friction. Let us look at this figure. You have a single wedge and two identical blocks. Two blocks each weighing 200 newtons are to be pushed apart by a 30-degree wedge. This include angle is given 30 degrees. So this angle is 30 means it's symmetric, it's 15 and 15. So the wedge angles are given 15 and 50, and phi, that is the limiting angle of friction, is 15 degrees at all contact surfaces. Wherever you have contact, here the contact between the wedge and the block and the contact between the block and the floor, you have limiting angle of friction is 15 degrees, and that's what is exactly the problem. And he is asking what value of P is required to start the motion, to start the movement of the wedge. Wedge is moving downwards, and these two blocks are moving away from the center. So this is exactly the configuration diagram. And let us look at this. The procedure is concerned. You have in a systematic manner you will be solving this problem. The very first step of the problem is free body diagram of the wedge. Why you are drawing free body diagram? Because the external force P is acting on the wedge. The force on which part of the body is represented, that is wedge. And this impending motion is down the plane. So frictional force is opposite to the direction of the impending motion. So that you will be knowing the direction of the frictional force, which is upwards, and on the contact body exactly it is opposite. And as this wedge is moving downwards, these two blocks are moving away from the center line or vertical line, and that is exactly the configuration diagram which is given. So you will be drawing the free body diagram of wedge, then followed by the free body diagram of a block, that is your second step. And third step is analysis using equations of equilibrium on the block. So you are interested in contact force at these two wedges. You see that at contact surfaces, and you are very much interested in contact force. After knowing the contact force, and finally you want to calculate the magnitude of the force required in order to have the impending motion of the wedge. And this problem you can solve using equations of equilibrium, or else you can solve by Lami's theorem also. So Lami's theorem, as you know very well, you can apply whenever you have three concurrent forces, you can go for Lami's theorem. So remember, only whenever you have three forces, you can make use of Lami's theorem. Otherwise, you can't apply Lami's theorem to solve the problem. And you have to solve by equations of equilibrium of these concurrent forces. Remember that either you can solve this problem by using equations of equilibrium, or you can solve by Lami's theorem. One of these two methods you have to adapt to solve the problem. Both are not required. You can adapt any one of these two methods. One method is equations of equilibrium, the other method is Lami's theorem. So to make you too comfortable, I will be solving this problem by both the methods. So let us proceed. Let us adapt the procedure. That is, first step is free body diagram of the wedge. Let us draw the free body diagram of the wedge. So first you draw the isolated view of the diagram of the wedge. I have drawn this wedge. Wedge is a part on which the external force is represented, and remember that the motion, the impending motion, is down the plane. So it is down the plane. Obviously, you can find that frictional forces are opposite to the direction of the motion. So this is frictional force F, and this is also frictional force F. And let us call this is left side is F1, the right side is F2. And this wedge is at an angle 15 degrees with vertical. So if you erect a perpendicular with horizontal, this angle is 15 degrees. And the result, this is your N1. Resultant of N1 and F1 is at an angle again. The limiting angle of friction is given, that is phi is given 15 degrees, and this is also 15 degrees. So that means with horizontal it is at an angle 30 degrees. Similarly, identically the other side also, you have a normal force N2 which is at an angle 15 degrees with the horizontal, and the resultant of friction and the normal force, that is R2 at an angle 15 degrees. So this is also R2 also with the horizontal at an angle 30 degrees. So this completes your very first step. Let me write it here. It is a free body diagram of wedge. This is the very first step of the problem. Let us proceed to the second step, that is free body diagram of FBD, free body diagram of the contact body, that is the block. So here in this particular problem you have two identical blocks. Two identical blocks. So whenever you come across with the symmetric blocks or wedges, you need not consider both. Let us consider only one, either left side of it or right side of the wedge. I am considering the right side of the wedge, that is this particular block. So let me draw the diagram of the block. I am drawing the diagram of the block, the isolated view of the diagram of the block. This is the diagram of the block, and weight is given, which is acting vertically downwards 200 newtons. And here we see that the frictional force, here it is acting vertically upwards, here exactly opposite to that, F2 is acting vertically downwards. And of course normal force on the body, N2, and which is inclined at an angle 15 degrees with the horizontal, and the resultant of these two, F2 and N2, is R2. This is acting at an angle again 15 degrees. So that means R2 is making an angle 30 degrees with the horizontal line. So this is the contact surface between wedge and the block. Now the block is also resting on the ground. Also resting on the ground, and as the wedge is moving downwards, the two blocks are moving away. So this right block is moving to the right. So the frictional force will be exactly opposite to that. Let me call this as F3, and the normal force is N3, and the resultant of these two forces, F3 and N3, is R3 at an angle, limiting angle of friction, that is 15 degrees. So this completes your free body diagram of block 2. So step 1 is the free body diagram of wedge, and step 2 is the free body diagram of the block. Now let us proceed to the step 3. The step 3 is, it is using equations of equilibrium. So you will be applying the equations of equilibrium on block. You will be calculating the contact force, that is R2. Then again going back to the analysis of the wedge in order to calculate the force P. So third step is, let me write the third step here, it is analysis using equations of equilibrium. It is, let me write using analysis using the equations of equilibrium on the block. Your third step is, this is the third step on the block. You are applying on the block, right? And let us write down sigma fx and sigma fy. First you write down sigma fx is equals to 0. Sigma fx is equals to 0. So this equation gives you, the component of R2 along the horizontal pointing to the right, positive. So that is R2 cos 30, and the sign convention is positive, and there is no component of 200 newtons in this equation because it's a vertical downwards. And R3, the component is pointing to the left, so that is minus R3. It is a sine, the sign convention, it is a sine 15 degrees. The component along the horizontal is sine component is equals to 0. So solve for R3. So you can write down R3 is equals to, if you take the go to the other side, it becomes R2 cos 30 divided by sine 15 degrees, and this value, using your scientific calculator, calculate that, you are going to get 3.35 times it is R2. 3.35 times it is R2. Yes, now you write down sigma y is equals to 0. sum of the forces along the vertical direction. See that weight is pointing downwards, it's minus 200 newtons, and the component R2, vertical component, that is again minus R2, it is sine 30. This angle is with horizontal it is 30 and vertical component will be sine component, and this component is cos component, and that is plus it is R3 is cos 15. Cos 15 is equals to 0. So substitute R3 value into this, you have minus 200 minus R2 sine 30, again it is a plus, R3 value is 3.35, R2 into cos 15 is equals to 0. So solve for R2 and you can take R2 as common and write down it is 3.35 into cos 15 minus sine 30 is equals to 200, and you calculate R2 value, you are going to get this value is 73 newtons. The value of the R2, so 200 divided by this value is 73 newtons. So after knowing this value, let us go back to the the last step of the problem, that is the fourth step. It is using analysis of wedge using equations of equilibrium. So this is using equations of equilibrium, analysis using equations of equilibrium on wedge. It is on wedge. So this is what is wedge. So here simply from sigma fx you can write down sigma fx is equals to 0. From this R2 original component is cos, it is R2 cos 30, R2 is minus, and R1, here this is R1, here it is, this is R1 and its component is plus R1 cos 30 is equals to 0. From this you can see that R1 is equals to R2, both are equal, and if you write this simply sigma fy, you are going to get the answer. Sigma fy is equals to 0, your p is minus p plus R1 is equals to R2, you can write down the vertical component R2, that is R2, 2 times R2 you can write down because both are equal, 2 times R2 into your vertical component is sine 30 is equals to 0, and 2 sine 30 gets cancelled, and your P is equals to R2, and that P value R2 you got it is as 73 newtons, and the answer is 73 newtons. So this is what exactly using equations of equilibrium. The same problem you can solve by Lami's theorem also. So let us analyze using Lami's theorem. And let us to apply Lami's theorem. Third step is free body diagram of block. This is what is block. And for that, let us represent coordinate axis vertically downwards. That is 200 newtons weight of the block. And this is R3 with vertical. It is acting at an angle 15 degrees. So this is 15, and this is your R3. R2 with horizontal at an angle 30. So this angle is 30 degrees, and this is R2. Find out the angles between the successive forces. So let us look at this. It is 15 plus 90 plus 30, that is 45 plus it is, this becomes 135. The angle between R2 and R3. So this angle, let us look at this, 180 minus 15, that is 165 degrees. And this angle is of course 60 degrees. 90 minus 30, that is 60 degrees. Now let us apply Lamb's theorem, and you are very much interested in R2 value. Let us write down R2 divided by sine of angle between the other two forces. It is sine 165 degrees is equals to the known force, that is 200, divided by the angle between the other two forces, sine of 135 degrees. And let us calculate R2 is equals to, it is the sine 165 divided by sine 135 into 200. This value you are going to get R2 value 73 newtons. So let us calculate using calculator. We get R2 value as 73 newtons. And the last step of the problem is, again you are applying Lamb's theorem, because you can see that you have three forces, 1, 2, 3, and let us draw the coordinate axis, and let us look at this. P is acting vertically downwards, and this force with the horizontal, it is acting at an angle 30 degrees with vertical. So with vertical it is acting at an angle 30. So it is with the horizontal, that is R2 30 degrees. Here also with the horizontal it is 30 degrees, that is R1 with horizontal 30 degrees. And if you calculate the angles between the successive forces, this is 120, and this is also 120, and this is also 120 degrees. So obviously all three forces are equal. So your P is equals to R3, and P is equals to R3 is 73 newtons. So when the angles are equal, all three are equal, and it is going to form equilateral triangle, and all the sides are equal. So this force is known, R2 is known, so P is equals to 73 newtons. Thank you very much for watching this video. For more videos, watch Ravi Second. Thank you.